Hi, it's Robin. I've got here the Penultimate+3dcr. It's the latest version of this multifunction cartridge for the VIC-20, developed by Tynemouth Software and produced and sold by The Future Was 8-Bit. I've made in-depth videos about some of the previous versions, so you might want to check those out for more coverage if you're interested in an aspect I don't talk about in this video. And just so you know, Rod at The Future Was 8-Bit sent me this cartridge free of charge with no conditions at all. I'll be covering what I find interesting about it, and you'll have to decide for yourself if I'm really just a shill for big 8-bit. The cartridge's designer, Dave at Tynemouth Software, has an excellent blog, and it was very useful to me as I was preparing this video. So links to my previous videos about this series of cartridges, links to The Future Was 8-Bit, and the Tynemouth Software blog will all be in the video description if you're interested. So just to start with an overview of this VIC-20 cartridge, at first glance it looks like the previous ones. It's a RAM expansion, anywhere from 0 to 35 kilobytes in any combination, which can be chosen from the built-in menu system. You might think, why would I want 0K expansion? Well, certain programs require it, and it'd be a hassle to have to unplug the cartridge for those times. You can just leave it in. But the new feature hiding in here is a 280K mode, which is that 35K in 8 separate banks of RAM that you can choose between with a single poke. We'll look at that later. It also expands the ROM, and now apparently has 271 programs built in. The majority of them are games, but there's also utilities, new and old, and it includes all the VIC-20 games that The Future Was 8-Bit has released. And here's the most dramatic change. It now has an SD card slot, and you can actually get this cute little, it's just an SD card with a sticker on it, but it looks like a little floppy. And you can stick that in there. So it's got an SD to IEC disk drive built in. And the other new thing is here on the side, it has this new jack. And that's so you can plug in this cute little cable with an IEC disk drive connector on the end, so that the disk drive can talk to the VIC-20 as if it's a regular disk drive. So I think this is an interesting solution. I was curious about how this was wired up. The tip here is wired to pin 5 in the top right, and that's the data line. Next to that is ring 1, which is wired to pin 4 down here in the bottom right, which is clock. Next we have ring 2, which is wired to pin 3 in the bottom middle, attention or ATN. And the final conductor on this 4-conductor jack is the sleeve, which is wired to pin 2, which is in the bottom left here, ground. It seems that pin 1 in the top left and pin 6 in the middle are not connected. That's SRQ for pin 1, and the middle pin 6 is reset. And I guess those just aren't necessary for the functions of this cartridge. So I thought it was a neat solution. It allows the cable to be easily removed. And if you don't have a use for the disk drive in a particular session, you don't have to plug this cable in at all. And then it's just like there's no disk drive plugged into the VIC-20. Do check the video description. If I made any mistakes there, I will correct them. All right, so just plug that in there. So you can see there's a decent amount of clearance here. I guess if you had one of those bigger adapters that's is it Sven Peterson designed, not sure that would fit. I actually don't think I have one, but so it just goes from the cartridge into the disk drive so that it'll work with the regular load commands and so on. Okay, so when you power up the Penultimate, it comes up to this main menu. So we'll look at the built-in ROM features first. Okay, the menu can be navigated either with the cursor keys, or it's all joystick controlled as well. And at any time you can return to this menu by pressing the green button in the top left, and it is labeled Menu. Down at the bottom is a settings screen, and you can decide what you want to boot to. So normally the default is the menu, but you can also boot to a random game, which is pretty fun. You can also boot to the file browser if you're more into disk use. Or you can boot into one of these combinations of different RAM expansions and cartridge expansions in some case. And I think I demonstrated all these in a previous video. Well, not Turbo Wedge, we'll get to that later, but Basic 4, Super Expander, which are just kind of alternate basic versions, Waterloo Basic. Or if you're really into the machine language, you can boot to various monitors and assemblers. I think I covered all those as well. Okay, for some people, all the games will be the highlight. Here they are, all alphabetically sorted. Scroll up or down, cursor right or joystick right, and lets you flip through a whole page at a time. And if that's too slow, you can hold down Shift and press the first letter. So Shift A, of course, brings you to the beginning of the A games. Shift G brings you to games starting with G. Okay, the cartridge also detects if you're running an NTSC or PAL VIC and just shows you the appropriate games. VIC-20 games are sensitive to PAL versus NTSC, especially, it's kind of quirky, but the screen placement is the main problem. If you run games for the wrong standard, the game is kind of shifted weird, often partly off screen. Okay, so this is an NTSC VIC-20, so it's showing the NTSC games. If you press P, then it will show all the PAL games. And if there's any games that don't work very well on NTSC, it'll put an X over at the right there. And you can go back to the NTSC list by pressing N. And if you want to just see all the games, press A. Then you'll see all of the games. And the ones that aren't compatible with your system have an X next to them. And you see that there actually are multiple versions of certain games. Atlantis, what else do we have here? Bandits, because they're actually different binaries to support one standard or the other. So the all mode shows you both of them, but makes it clear which one is and is not compatible. Okay, and certain games will have a K next to them. That means you can adjust the screen using the keyboard. And some games will have a J next to them. And that means that they can actually be shifted with the joystick. Okay, besides the alphabet list, you can also look at games by category. And this, as I mentioned, all the future was 8-bit titles. So there's some really great games in here. I think I did a whole video about Emu's Massive Hunt. And some of these other ones I've covered before too. Lots of good games. And there's other categorized games like Blitz, Centipede, Pac-Man type games. And there's even a few that are kind of special categories like paddle games. Paddle games are kept out of the main mix because a lot of people don't have paddles hooked up. Or if you're just choosing a random game, you probably want it to be a joystick game so you're not stuck with one of a small number of games where you have to go grab paddles for it. A lot of these games were on it already. Apparently Android Attack is a new one. Let's try this. Now those are sound effects. What do I do? Written by Stuart Hall for Abrasco, 1983. Do you require the instructions? No, of course not. Press F5 to play. Okay. I am. What? Oh. Seems like actually... Oh! Oh, man! Was that a super out of tune Star Wars theme? Okay, the best strategy is to sit still and keep shooting. Oh man. What? Why couldn't I shoot that guy? Oh. Okay, well, it's got auto fire. That makes it easier. Oh. That was like... Okay, well, that was worth it just for the music, I think. Okay, I'm kind of dwelling on this a bit too long, but just so you know, yeah, there is this random ROM runner, which is a lot of fun. The utilities section has a bunch of utilities. Yeah, very useful. Some people would be the VIC-20 dead test. And now if your VIC-20 is too broken, like the keyboard or something, and you can't start the dead test from here, there's a neat feature. If you have the computer off, hold down the right hand button and power it up, and then let go, and it will come up in dead test mode. Okay, and this does a test of your VIC-20. So it's a handy feature. And because there's a lot of confusion about this, the self-test, self means the penultimate, not the VIC-20. So run self-test, and it will make sure that your penultimate is working properly. We'll come back to that online help. And the other thing here is these development tools. And this is what I think I went into great depth in a previous video about the monitor, programmer's aid, super expander, wax assembler. All these are various programming, either languages or utilities. Check that previous video if you want to see more about that. They're a lot of fun. Okay, for the utilities, and the one last thing in the ROM here, that last option, online help, where you can actually just press H on the keyboard. The help system is now its own program that loads in pretty much instantly. It used to be built into that menu system itself, but that really constrained the size because that menu program is already kind of a huge program. So by breaking it out here, it's now way more detailed. So here's the main menu. I probably covered a lot of these, but here's all those nice little shortcuts. Let's flip through these. You can configure the RAM. We'll be looking at that in a moment, but there's the various keyboard shortcuts. The file browser. Turbo Wedge, we'll get to all that later. That's nifty. So if we go here into the advanced memory config, so this shows all the different RAM configurations that it can do. Now, if you don't know about the VIC-20, you might ask, why not just have the maximum RAM all the time, which was 35K. We'll talk about the 280 separately. That's the new feature here. But why not just use 35K all the time? It all comes back to some questionable design decisions that were made when the VIC-20 was coming out. I think that the VIC-20 and actually the VIC-1001, which is actually the original VIC machine that was released in Japan in 1980, and the VIC-20 was released in the rest of the world in 1981. When they were designing that machine in 1980, I think they wanted to make it an 8 kilobyte machine, but it ended up shipping with 5 kilobytes. And I think that was just one of many cost-cutting measures. The machine would have been quite a bit better, well, certainly a lot simpler, if it just shipped with 8 kilobytes. So that's why there are very strange RAM expansions like 3K. So I'll put a picture of a VIC-20 memory map on here. Thanks to Jeff Daniels for making this excellent diagram. The 6502 processor pretty much absolutely has to have RAM down at the bottom, starting at location 0 and working up from there, because there's something called zero page in the first 256 bytes. So it was kind of non-negotiable that there would be 1K down there. Then they pulled 3K of RAM from the memory map and just left a hole there, and then another 4K. And then that's why they started selling a cartridge with just 3K of RAM on it, which plugs that hole. So that's why we have this SetRAM 3K. It's a bizarre RAM expansion, but what that does, instead of a 1K and a 4K section, creates a contiguous 8 kilobytes. And the weird thing is that the VIC-20 reconfigures itself based on whether it does or doesn't have that hole plugged. And then the VIC-20 does these configurations where screen memory changes and basic memory changes depending on how much RAM you do or don't have installed. So that's the reason why they're providing such granular RAM upgrades, because these were all unique, well, not all of them, but the 3K and the 8K are two distinct ones. If you look on the right there where it says 3 and 8, that 3K goes in a different spot than where the 8K goes. And I don't think anybody sold an 11K RAM expander back in the day, but if you do want to plug the 3K hole and put 8K in, you can with this, and every other strange combination that has any use. As you see, 35K expansion is the maximum, where the 3K hole is plugged. Then you have 3 8Ks, that makes 24K, added to the existing 5 plus 3K, so that's 32 kilobytes, same as the Commodore PAT, I don't think coincidentally, and that was the normal maximum for an expanded VIC-20 back in the day. There's also an 8K area that's actually for ROM cartridges, but there's nothing stopping you from putting RAM in that spot as well. So that's where 8 more K comes for a total expansion of 35K, plus the 5K that's already built in, a total of 40 kilobytes of RAM. And quite a bit of software is sensitive to whether you've got the 3K or the 8K and so on, and where screen RAM is and all that sort of thing. So that's why it matters that you have all these options available. Almost all brand new software actually expects a 35K expansion. That brings us to the new feature here, 280 kilobytes. And that is the same 35 kilobytes, but switchable between 8 different banks. So all that RAM is available, but only 35K at a time can be mapped into the VIC-20, but it can rapidly switch between them, and you end up having, 280K available. Okay, so let's just play with that briefly. You can choose that here, and then exit to basic. Okay, notice it doesn't say 280K free or even 35 or 40K free, but that's just because that 3K isn't included. That's non-contiguous. That upper 8K where the ROM cartridge would normally be isn't included. So you take the 40K, subtract 11K, and you get about this amount here. There's a bit of overhead that basic uses. I'll do a bit of a demonstration of the disk drive features as well, so that we can show the 280K at least a little bit. So if I just type $ and press return, it will do a disk directory. So this is what's called a disk wedge. You don't have to type in that tedious load quote $ quote comma 8. And even more importantly, in addition to just being shorter, where the load command would actually erase any program in memory and the disk directory would become the current program, essentially. This DOS wedge, the $ command, just shows the directory on screen non-destructively, and your program, if we had one, would still be there. Okay, we can also issue commands if you use the @ symbol, CD, and then we type in SuperMon. This is Jim Butterfield's famous monitor, machine language monitor. And if we do a directory there, okay, well, there's a whole bunch of stuff. I can't remember where I got all this from. Grungy towers. Okay, but the first program is SuperMon.v. I guess that means SuperMon for the VIC-20. All I know is it works here. And if we list it, there's just a small basic stub. And what this program actually does is installs into RAM. And it does a little calculation to find out where it's being loaded to. So it actually will work with various configurations of VIC-20. Maybe even works on C64. I actually didn't test that. Okay, Let's try running it. Okay, so here we are in Super 64Mon, and we can look at RAM. So the beginning of the 24K block of RAM is at 2000 hex, and we can look at it there. And we can modify memory. It automatically puts a colon there because of the VIC-20's narrow screen. It just shows 5 bytes at a time. That's okay. Let's just put 2 00s in there, and we can check that those actually went into RAM there. Okay, now I think we have the 280K RAM mode available. So if we look at memory at 9806, this is the register that lets you change banks. Now, I think it's write only. That is, I don't think there's actually a 4F in there. That's just coming back for whatever reason. But you should be able to put a number between 0 and 7 to choose one of the 8 banks. Okay, so I've put a 0 in there. I'm going to try it, and I think... Okay, so we were already in bank 0, so that had no effect. So now if we go to 9806, I'm going to go to bank 1. And we crashed. I actually knew that was going to happen. I just thought this would be a dramatic example. Okay, so why does it crash? Well, it's crashing because this SuperMon program right now is in memory at around 7,000 to 8,000 hex up in that area of RAM. Well, when we change the bank, it's all that RAM goes away and another 35K comes in and there's no SuperMon there. There's just, I guess, random uninitialized RAM. So that's a problem. Well, that could be a problem for any program. It's not insurmountable. You just have to be aware that it'll happen. Now, how can we use SuperMon? I just want to use SuperMon to play around with this just briefly here. We need a workaround. Okay, so we can do that. We're going to reset to the menu. Oh, I didn't mention that the function keys provide shortcuts to different RAM expansions. You see F1 through F6. And the R key, you can actually rotate through all the different sizes of RAM, including, I rolled by it there, including 280K. Now, that's tedious, but if you press E, it automatically goes to 280K. And then you can press Q to exit out to basic. And then we should still be in that SuperMon D64. So here's our program. Like I was saying, SuperMon installs itself up in the top of basic RAM as high as possible. It just does that automatically. But that's part of the problem, is that it's installing itself up in that banked RAM. We want to install in somewhere in the 5K of built-in RAM, which doesn't switch when you change banks. How do we do that? Okay, well, if we print peak 55 and peak location 56, we get back 0128. In hexadecimal, that 128 is the same as 80 hex, and of course 00. So that is 8,000 hex. And that's the top of that main contiguous RAM expansion, which I said starts at 2,000. And at 1,000 is that 4K of built-in RAM block. Okay, so what we just have to do is tell BASIC that the top of RAM is actually 2,000 hex. If we print free, it'll tell us we have 25 kilobytes free. Okay, so all we have to do is poke 56, and instead of 128, which is 80 hex, we want 20 hex, which is 32 decimal. Okay, so we do that. We do a clear to reset the pointers, and now if we print free, now we only have 1 kilobyte free. But of course, SuperMon is here in RAM already. Oh, I hope this will work. I'll list it. Okay, and now I think if we run it, there we go. Okay, so now SuperMon's installed in RAM, and you see by the PC counter, it's running down in that 1,000 to 2,000 block. So I think we're fine. We'll look at location 2000 again. There, our zeros are still there. Now we'll look at that 9806. Okay, and we want to change, we're back here again. We're going to try and change to bank 1. Okay, that question mark appeared. I actually haven't found documentation on this, but I think that question mark means SuperMon doesn't think that that write actually worked. So I guess it writes, and then it reads it back and checks if it's there. And like I was saying, so if I go 9806 again, oh, whoops. Sorry, guys. 9806. Yeah, that 4F is still coming back. So like I said, I think this register that lets you switch banks is write only. And so I think it was able to put a 1 in there, but then when it read it back to verify it, there wasn't a 1 there. So it prints that question mark. But anyway, let's look at memory at location 2000. Okay, so now you see there's an EC and an AA there. And it didn't crash, obviously. Okay, so since we're in bank 1, I'm going to put 0101 back there. Okay, so let's go back to bank 0 and look at memory at 2000. There's our zeros. Let's go to bank 1 and look at location 2000. There's our 1s. That's my super convoluted way of showing that there's bank switching going on here. And if we go to 9806, we can go all the way up to bank 7. And if we look at memory there, okay, there's a 12 there. Like I said, this is randomly initialized. So I'll put a 7 in there, just indicating that we're in bank 7. And there's the 7. If we go back to bank 1 and look at 2000, there. Okay. So you can see that, yeah, obviously we have 8 banks here. So if I go to like C1000 where BASIC lives, I try to put a C0 in there. You see how there's a question mark there? And that's because this is actually ROM. That's the SEI instruction, I think, hex 78. But if I go to A1000 and try to write whatever, A0 in there, see, no question mark. And that's because this is that block of 8K of RAM that's up in that part of memory. And if we look at 8000, there it is. Okay, so I'm pretty sure that's what's happening with that question mark. Okay, and just to look at the disk drive a little bit more, I think I pointed out that it says Turbo Wedge active there. So the SD to IEC SD disk drive that's built into this, and that I use other variations of it in most of my episodes, I think it talks both the JiffyDOS protocol and the fast load protocol. So I think this is using the fast load protocol, but the fast load shell is pretty wonky. So I think it's using the JiffyDOS style shell commands. But I don't think it's like a clone of JiffyDOS. For example, if you hold down Shift and Stop, it's still able to load from tape. JiffyDOS is not able to load from tape because the JiffyDOS routines actually replace the tape routines in the kernel ROM. So that's kind of neat, still having that. If you type the number sign, it'll show you what disk drive it's currently referencing. And if you want to change to device 9, but we don't have one right now, you can. I guess you need a Y cable to use this with another disk drive, which are available. I know Jim Brain used to sell them. They're handy. But how often do you need 2 disk drives on a VIC-20? Not too often. Let's go back to 8. Instead of the load command, we can do a bunch of things. There's the / command, which will load it as a basic program, the same as just typing "8". If you use the %, it loads it as a machine language file, as in the same as "8, 1", loading it to the address it was saved from instead of the beginning of BASIC. Unless it was saved from the beginning of BASIC, then it'll go there. Up arrow loads it as a program and runs it automatically. Back arrow will save the file. You can also do a selective disk directory if you do $, and then some sort of string with an asterisk for a wildcard. It'll display all the files that start with the letter S, for example. Or if you just wanted SU, you can do that too. You can get the drive status by typing the @ symbol. There we go. And that tells you what the disk drive is doing. Actually, I want a power cycle. I want to see what it says when you first power up, @ symbol. So that's a little neat thing. Basically, every Commodore compatible disk drive, if you have one of these wedges, you type @ symbol, it'll actually get the boot message from the disk drive. So here we can see it's an SD to IEC version 10010, whatever. I don't know, I guess that's the revision. And that's also useful if you've done a disk command and it didn't work, you can type that and get an error message back. Now, Super Snapshot allows you to use both the @ symbol or the > symbol to send wedge commands. I'm not sure if anyone else does this, but apparently here, if you type the @ symbol, it will actually wait for a response. But if you type it with the > symbol, it will just immediately return back to BASIC and let the disk drive handle that. So that's kind of neat. Okay, I already showed you the change directory, which allows you to both go into disk images like this SuperMon.d64, but also lets you go into directories like, for example, this VIC-20 directory. It doesn't really care whether it's a native directory or a disk image. It basically behaves the same. So if we do a directory now, we're in this directory. You can see all these different VIC-20 programs are split up with a directory per letter. So if we change directory to E, and then we can do a directory again, I guess they're all games. If we go back directory, do that, we go back 2 levels. I just entered that in twice. Change directory to the back arrow. Okay, and now we'll see we're back in the root. I want to go into that SuperMon D64. I'll make a little program here like temperate high, back arrow, save it as high. And now I can do a disk directory. You can see that the file is there. Okay, and we can do a few other commands like copy. And we can make a file called high2, which is just a copy of high. So now if I do a directory of high, you see both of those files are there. If we decide high2 is not a very good name, you can use the R command and then the new name. So you think high3, that's a much better file name. There, so now we renamed it. And if we do a disk directory, you can see the files being renamed. If we decide we don't even like high3, we just want to just get rid of that file, we can go @s for scratch and then high3. And now it reports back that the file has been scratched. And we can confirm that. There, it's gone. Okay, we exit back out. And there's also an MD command if we want to make a directory. I'm obsessed with high today. Okay, there. And you can see it's made a new high directory. It wraps around here to the next line. And then we can go into that and do a directory. And now we have this empty directory ready to fill with whatever we want. That reminds me, I didn't mention yet why it's called the DCR. That's a little tribute to the Commodore 128, which was the 128D-CR cost reduced. As I've mentioned before, cost reduced wasn't actually a bad thing with Commodore. It was actually usually better because in addition to making it cheaper, they actually usually made it better in a way, like longer lasting, usually more reliable, runs cooler, all sorts of things. In this case, it's kind of a nod to the fact that the Commodore 128D CR has the disk drive board built into the main computer board, just like this has the built-in SD2IEC all on one board. Just thought I should mention that. Okay, so here, let's boot to random game. Oh, Serpentine. Hey, I just got that from Uncle Mike there. Oh, I'm the purple one. Okay, so that is a look at all this. Thanks to Dave and Rod for making this great cartridge. And, you know, just having such a great thing available for the VIC-20. If you don't know what to do with your VIC-20, then, well, this really is like a very good thing. If you get bored of this, you're just bored of the VIC-20, unfortunately. Well, unless what you like doing is programming or something like that. Okay. I'm not paying attention here. Let me try, I just guess I'm trying to eat those things. Those frogs? Well, there I got one. Okay, so in that 280K mode, what do you think should be done with that? Dave says he's hoping somebody makes a monster 280K game. That would be pretty cool. I actually had an idea for the 280K. That wouldn't be a game, but I didn't get it working in time for this video. Maybe I'll get it working. I don't know. I gotta see if I can figure out why it wasn't working so good. But anyway, I'm interested in your ideas. Do you have ideas for what a 280 kilobyte VIC-20 can do? Oh, what's that? Okay, so be sure to check out the links in the video description to the Future Was 8-Bit website or the Tynemouth Software, or if you just want to watch other 8-Bit show and tell videos about this cartridge or whatever else, check the video description. Thanks to my patrons for their support. Thank you for watching, and we'll talk to you next time. Ooh, Choplifter by Tom Greiner. This is both so ugly and so awesome. This was actually a pretty amazing technical achievement for the VIC-20 back then. Oh, come on. No! Blowing up all the people. There it gone. Come on, people. What, can't you get in? Or are we full? There we go. Okay, that's really it. Bye!